Okay, let's talk about the fundamental theorem of algebra. It's not as intimidating as it sounds. We can talk about the origin of it when we get back together. But the fundamental theorem of algebra says that if a function has a degree of n, then that function has n linear factors, right? So every factor can be written with the first degree of x. And this value of c is an element of the complex number system. So what that means is every single factor can be broken down into linear factors if we include complex numbers. Okay, and that's what this says down here. If you just look at a real quick example, what this one looks like. Okay, let's see if my tools work here for us. Probably will. So this is a third degree polynomial, which means that it has to have three linear factors. And if it has three linear factors, that means that it has to have three zeros. Now, those zeros may be real numbers. They may be complex numbers. So if you were asked to find the zeros of this function by setting it equal to 0, okay, the first thing what we do when we find zeros, remember, we've got three options, okay? Option number 1 is to factor. Option number 2 is to graph. Option number 3 is the quadratic formula. Okay, so in this case, when you look at this, option number 1 is always going to be to factor, and we can factor, right? There is a greatest common factor here. So we can factor the x away from this. So we end up with x squared plus 4. So in this factored form, we see one of the zeros here. Now, this is a quadratic factor. So according to this fundamental theorem of algebra, this can be broken down, okay, into linear factors. Now, we did talk about this at one point. This is in your notes. You can go back and look this up. This is what we call the sum of squares. And again, it is in your notes. The sum of squares can be broken down into conjugates, right? The difference of squares, let's go over here. The difference of squares, we know, can be broken into x plus 2, x minus 2. We've seen that enough at this point. That should be automatic, right? Factoring the difference of squares into conjugates. The sum of squares can also be broken down into conjugates, but the conjugates that we factor this down into are what we call complex conjugates. Okay, so we have to put an I with our answer. And if you don't believe me, go through the process of foiling this. X times x is x squared. X times negative 2i is negative 2ix. X times positive 2i is positive 2ix. And positive 2i times negative 2i is negative 4i squared. These terms cancel out. I squared is equivalent to negative 1, we end up with x squared plus 4. So this is why our sum of squares can be broken down into complex conjugates like this. Now from here, the process is the same as what it was when we were dealing with real numbers, right? Every one of these factors can produce a product of 0 if they are equal to 0. So we could say that this x in front produces one of our zeros. We have the 0 that comes from here. Remember, we also said in class, if the degree of x is 1 and the coefficient is 1, then the 0 that we get from this is the opposite of that constant value in the back of that binomial. So we end up with x equals negative 2i and x equals positive 2i. So we started with a third degree polynomial. We ended with three linear factors that produced three zeros. Okay, we did this by factoring. Okay, we'll see a different example here in a second.